Describe the method which can be used to separate two compounds with different solubilities in a solvent. Now, in a solvent, I think there is no S required here. Simple correction, but many times students find this very difficult to comprehend. So let me support this with an example also along with the explanation. Let us say we have two substances. Let's say we have something like NaCl, which is sodium chloride. The sodium chloride or salt, common salt, water soluble, it's very much water soluble. And let us say it has a solubility of 200 grams per liter. This is not the exact figure. I'm just saying a random round figure so that it feels good and it's easy to calculate, and it's a close figure. It's a good example. And on the other hand, let's take something like, say, magnesium sulfate. And say, although magnesium sulfate is reasonably happily soluble in water, let me assume that, say, around 40 grams per liter of magnesium sulfate dissolves in water. So these are the solubilities. So they have different solubilities. Yes, they have different solubilities, and they have been mixed. Now, had I had something like NaCl and something which is water insoluble, it would have been very simple. I just add water, NaCl dissolves, and the other substance does not dissolve. I can filter and separate. The problem is both of them are water soluble. If I have them mixed, and now I'm asked to use water to separate them out, how do I do this? Well, there is a beautiful method. And what is that method? Let me relate that to you. Say, these are the solubilities, and I am given a mixture of NaCl and MgSO4. And say, for example, and please note, there is no necessity that the mixture would have NaCl and MgSO4 in this ratio only. It could be any amount. Say the mixture contains 200 grams of NaCl and say it has 80 grams of magnesium sulfate. Anything of that kind. Any stupidity. Fine. Now what do? Well, I know very well that for dissolving magnesium sulfate, I need how much? 40 grams per liter. That means 1 liter I would need for dissolving 40 grams. If I have 80 grams, let me say I need how much? 2 liters. So what do? I keep on adding water to this mixture and keep on adding water till both the salts dissolve. And in this case, I would need, say, initially 2 liters of water. For 40 grams, I needed 1 liter. So for 80 grams, I need 2 liters. But now you will say that for 200 grams, you needed 1 liter. Fine. So now you have 2 liters, right? So in 2 liters, 400 grams of common salt, NaCl can dissolve? Yes, they can. But I just have 200 grams. If I have less, will they dissolve? Yes. If I have more, then they will not dissolve, right? So I have a solution. What did I do? I had a mixture of solid NaCl and MgSO4, and I kept on adding water and water and water till both of these dissolved. And now I just used 200 liters of water, 2 liters of water, and both of them dissolved perfectly. What do I do now? Let me start boiling this. If I start boiling this, what happens? Well, water evaporates, and as water evaporates, and say this 2 liters of water, if I boil and reduce it to 1 liter, what happens? From 2 liters, within this 2 liter, I had 200 grams NaCl and 80 grams of MgSO4 dissolve. Yes. Now, when the water volume has been reduced to only 1 liter, what happens? You can see very clearly that in 1 liter, 200 grams of NaCl, which is more soluble, can still dissolve. So yes, I still have 200 grams of NaCl very much. So I have 200 grams of NaCl, right? But in 1 liter, only 40 grams can dissolve. Yes, and I have 80 grams. So what happens? So 40 grams of MgSO4, they will remain in the solution. Yes, but 40 grams of MgSO4, what happens to them? They crystallize out. It crystallizes out. You get solid crystals of MgSO4 and there is no NaCl. It's pure lovely crystals of MgSO4 crystallizing out. Why? Because within 1 liter of solvent or water, not more than 40 grams of MgSO4 can remain. So the remaining 40 grams out of 80, 40 has to remain. Remaining 40 has to come out. So from a mixture of NaCl and MgSO4, I have got 40 grams of pure MgSO4 separated, right? Right. This is a process which is called fractional crystallization. Now, just let's take a look at this in a more formal way. It's written here, fractional crystallization. It is crystallization, not distillation, of course. That is wrongly written here. I'll just move aside. Take a look. Fractional crystallization can be used to separate these two compounds with different solubilities in solvent S. You find that first you take a powdered mixture, you add solvent, keep on stirring it, warming it till you find that the solid mixture totally dissolves in the liquid and you have a saturated solution. Fine. Now you boil that solution. As you boil the solution, you find, and you can filter it also at the same time, after some time, you would find that, like in our example, MgSO4 had crystallized out. The less soluble salt will begin to crystallize out. The less soluble salt begins to crystallize out. So you can collect those crystals very nicely. Now you might say that, sir, you separated 40 grams of MgSO4, fine. But then there was some NaCl and there was some MgSO4 still remaining in the solution, very much. What happens if you further crystallize that? If you further boil the solution, now you find that since the solution, in our previous example, the solution did contain 200 grams of NaCl and 40 grams of MgSO4, if you boil it further, you would find some salt will also crystallize and some MgSO4 will also crystallize. It would not be any further possible to separate these by this method. This much you have got pure, and that is the limitation of fractional crystallization. So this technique is useful only when there is a significant difference in the solubilities. Please note, that would be a very key and important factor. But nonetheless, as far as the method goes very well. First, you boil, then the less soluble salt crystallizes out, you separate it, and then the classical method says once the less soluble salt is separated out, you further boil it so that the more soluble salt also crystallizes out. But please don't forget, the last installment, the more soluble salt, when it crystallizes out, it will definitely contain some traces of the less soluble salt. This is not clearly mentioned here, but that is always the case for fractional crystallization. This was fractional crystallization for you.